Hi everyone, we're going to be covering sampling designs and bias. Our first sampling design is simple random sampling. Simple random sampling is a common and, like the name implies, simple method for choosing a sample. We number all the individuals in a population in your sampling frame or list of individuals to be sampled from 1 to n. In the picture, we go from 1 to 12. Then, using a randomization method like a randomization table, random number generator, or just papers from a hat, randomly choose as many numbers as you want the size of your sample to be. In this case, we would generate 4 random numbers. The numbers selected or generated correspond with an individual in the population, and these individuals will make up your simple random sample.
In stratified random sampling, the population is split into two groups, or strata. These strata should be homogeneous within themselves. Individuals in each strata should be similar. In the picture, they are grouped by color, and different from each other. Then run a simple random sample as described in the last section on each of the strata. Once you select the individuals from each stratum, combining them together gives you your sample. Stratified random sampling helps to reduce sampling variability. It ensures that every sample will have at least one individual from each stratum. For example, in the picture, there is no way that our final sample will have no blue individuals.
Just like in stratified random sampling, in cluster sampling, the population is split into groups. This time, they're called clusters. The clusters should be similar enough to each other, but the members of each cluster should be representative of the population as a whole, sort of like small representative samples of the whole population. Then, number each cluster and perform a simple random sample of the clusters, not of the individuals in the clusters. Once you select the clusters, sample every individual within those clusters. For example, in the picture, we randomly selected clusters 3 and 6, and then we will sample all members in those clusters, 5, 6, 11, and 12. Cluster sampling can often be easier to implement than stratified random sampling, like sampling whole classrooms instead of individuals out of every classroom in a school. As a reminder, here's a randomization table. To use one, you work in a set amount of digits, the number of digits of the highest label of your individual labels. In the pictures on the other slides, the highest label is 12, so we use 2 digits at a time. Look at each set of digits starting at the beginning of the table. In this case, the first number is 11, so we would sample individual 11. Then the next number is 16, not included in the set of 0, 1 to 12, so we ignore it. We also ignore duplicate numbers if we are sampling without replacement. Also, be very careful and remember to put a placeholder 0 in front of numbers that have a small amount of digits. For example, in the 1 to 12 example, we need to make sure we look for 0, 1, not just 1. You can generate random numbers using your calculator instead of a randomization table if you prefer that. You can do so by pressing Math, going to Prob, and then pressing 5 for randint. If we were choosing from 1 to 12 again, we would enter those numbers in for lower and upper. We would then choose how many numbers you want to generate at a time. Your calculator will then give you the random numbers that you need.
It's important to try to avoid bias in sampling. There are several common biases and ways this can be done. Convenient sampling is when you only select individuals who are first or most convenient to sample. There may be some commonality between the people that would make the sample not random. For example, if you only sample the first 20 people to arrive at school, they're all probably early risers or people who care about getting to school on time, making them not represent the rest of the population. Voluntary response bias is when people have to choose to include themselves in a sample. For example, if a news show holds a survey and asks viewers to call in to participate in the survey about political views, it may only attract people who take the time out of their day to participate, which would be people with strong political views. Non-response bias is when people randomly selected to take a survey don't participate. Phone surveys especially have notoriously low response rates. For example, people may screen their calls and not answer phone surveys after they have chosen to participate. Undercoverage is when part of the population is not included in the sampling frame, often unintentionally. For example, if a survey is being run by calling landlines, people who don't have landlines will not have any chance of being selected to participate. Wording can also affect how people respond to a survey question. If it's provocative or biased, people may answer differently than they would if the question was more neutrally worded, as we saw in our first projects. Providing more or less information may also impact how people feel about a given topic. This FRQ from 2011 directly relates to the information we discussed. You can see the original problem, its solution, and its scoring guide on the AP website.